Today, we have a product at Spot called Ocean. So what Ocean is going to provide is going to allow you to manage the underlying infrastructure and save you up to 90% on the overall cost of the compute infrastructure. We do this by allowing the container to drive the scaling events, both up and down. And ultimately, we're going to simplify the operations and allow you or your DevOps team to focus on managing the pods and deployments or the revenue generating items. So we will save up to 90% by leveraging different pricing models, which is going to be spot instances, the excess capacity, or any pre-bought commitments. We work with any control plane. So today, if you have a managed service such as EKS, ECS, AKS, GKE, or maybe you're doing a self-managed like COPS or KubeSpray, those are all managed control planes. Ocean takes the same methodology, but applies it to your data plane. So we are going to manage the data plane and those worker nodes on your behalf. So what we're going to do is by looking at the specific CPU and memory requirements of your pods and deployments, we're going to ensure that every single one of your pods and deployments will have some place to be scheduled, and therefore no manual intervention is required. Secondly, we're going to maximize that resource allocation of each of those instances by picking the best suitable instances in real time. Secondly, we want to go one layer further. Many exercises that engineers oftentimes don't favor is truly sizing their application. What are the true requirements of their application? How much memory, how much CPU? We have baked into our product, we will allow you to determine from a vertical container autoscaler perspective, what is really the
Uh-oh.
Second, we have a cost showback. So in a Kubernetes environment, oftentimes you are running multiple services, multiple teams, multiple customers' environments, and we need to show what is the price breakdown on those shared resources. So this gives you all that visibility. And lastly, we want to be platform agnostic. And what that means is we want to integrate with whatever tools you currently have today. So Ansible, Terraform, and CloudFormation are all things we support out of the box. And we're going to make sure that you can add them directly into your existing stack, templates, etc. So let me pause there. And before I jump into the demo, I wanted to see if there are any questions on kind of what I've presented thus far.
There's one question in the chat room. I'll read it out for you. Tony C says, in production, there's a lot of talk about man-made CPU, but is network saturation per node ever a real concern? Is this something to consider in regards to how we design things? A few large nodes versus a lot of small ones?
Yeah, Tony, that's a great question. So first and foremost, every management plane have limits on how many pods can be placed on a single instance. And typically by default, Kubernetes will set that to 110 pods per node. Now, if each of your pods require its own ENI and its own network interface, you can imagine the network may be of concern. So definitely something to consider. Benchmarking will need to be an exercise to really get to the best answer. But typically what I've seen in my experience is typically the larger instances that begin to have more and more pods will begin to see a larger degradation on the network layer, simply because there is a lot of traffic that needs to go through the Kubernetes environment, similarly to the load balancer. So it's really depends is a short answer, but I would say a few large nodes does not work in everyone's case.
have a question.
Mhm.
So implementation wise, you're saying you can do from Terraform or other things, you're creating the node pools for whatever, like GKE or groups in EKS, and you're managing those groups?
Exactly. We'll be managing the node groups. So in GKE, they have node pools. We would
Mhm.
effectively be managing those node pools on your behalf.
Okay, and then you'll create whatever size you think my Tetris thing needs.
Exactly. We'll do that all in real time. So if, assuming you have a pool of developers who are all throwing different applications, different requirements,
Mhm.
we'll determine what the best instance type and size all in real time. Whereas a native Kubernetes approach with an auto scaling group does not have that flexibility.
Okay, and then so would I still try to do like taints and tolerances, or how do you handle that?
Exactly. So we will, from the Spot side on Ocean, we support all native taints, labels, selectors, affinities that you may throw into the scheduler. And again, what's important is we are just managing the underlying infrastructure, and we allow Kubernetes to schedule those pods, and they'll make sure to respect any of those items.
Hmm. So you'll create the instance groups too for with those taints and tolerances.
Exactly.
Cool. There's another question.
Mhm.
Ocean from Prashant. Prashant. Hope I got that right. Ocean sits in the provider's control plane like GKE.
So we're managing the underlying infrastructure, which means we are essentially going to spin up the infrastructure on your behalf inside your public cloud account. So we do this with, if it's GKE specifically, with service accounts. We actually do not have access to kubectl. We are simply listening to the Kubernetes scheduler, and with that information, we'll spin up the infrastructure on your behalf so that the scheduler can place those specific services or pods.
Cool.
Okay, well, let me, if there's no other questions, I'll just go ahead and kind of dive into a quick demo, maybe about a couple minutes, and then we'll open it up one more time for questions, and I'll pass it back over. So again, as I mentioned, the main goal for Ocean with Kubernetes is how can we effectively help users of Kubernetes solve the issue with scaling. So oftentimes the application will scale much faster than the underlying infrastructure, and there becomes waste. So what we do is we're going to shift those instances to be running on the different pricing models across the various clouds. What this allows us to do is we'll maintain that infrastructure and leverage those pricing models, which will give you the greatest savings. So here's an example where the cluster, we've moved 164 nodes from on-demand over to a excess capacity spot instances or preemptible VMs if you're on GKE, or low priority VMs if you're on Azure. And what we've done is this allows you to capitalize on the 90% savings, where we can manage those nodes and ensure that if there are any interruptions, we will shift your workloads so that you will never lose capacity. And we offer a 4.9 SLA. So just real briefly, what you'll see here is because we are enhancing the scheduler, we want to make sure that we use a variety of different instance types. And what this allows us to do is correctly maximize each of these instances as much as possible for the specific requirements of those pods all in real time. Okay, so you'll see what we've done is just a variety of different instance sizes that best fit those specific pod requests as all of the pods are coming in with different requirements. And then as I mentioned, we do the right sizing, which is the vertical pod autoscaler. So again, one of the struggles with the vertical pod autoscaler in Kubernetes is it will begin to increase your deployment's requirements. But if your underlying infrastructure is not able to scale accordingly, for example, let's say I'm using M5 larges in AWS, which have only 2 cores, and my vertical pod autoscaler increases my application from 1 core to 2 core, I have now ultimately caused the scheduler to unable to place that node, that pod on the node due to there being insufficient CPU. So what we do is we make sure to itemize as well as create recommendations so that you can see what am I currently requesting and what is actually being consumed. And what this allows you to do is to see how can we improve the overall cost as well as usage of my infrastructure. And then lastly, shared environment with Kubernetes, you need to see the breakdown of the costs. Oftentimes we'll run different namespaces, different tags, different deployments, and we want to see what is the cost in dollars across your environment. So this is really important if you're doing any cost showback, etc. And then lastly, all the visibility is here baked into the platform. And again, just want to capitalize on this is solving a lot of scaling issues today that Kubernetes oftentimes causes. And we want to allow users of Kubernetes to focus their time on developing the applications themselves versus worrying about the underlying infrastructure. So again, I'll open it back up to questions. And again, I appreciate everyone's time.
Thanks, Steve. Steven. Any questions out there? I'll kick it off. I got a question. This sounds all great. I mean, this is exactly what I want for my Kubernetes cluster. How much does this cost?
That's a great question. So we are a success-based company, meaning there are no fees up front. It is just a percentage of the savings, meaning if we do not save you money, we charge absolutely nothing. So this is a win-win. We're going to help you save, and we'll just take a cut of those savings.
Mm-hmm. And how big is that cut?
By default, it starts at a 20% with a pay-as-you-go. And if you do any commitments similar to the public clouds, you'll get further discounted for commitments.
So if you save me $100, I pay you 20.
Exactly. So you walk away with 80% or $80 in that example, and a bunch of time saved because you're no longer doing all those manual interventions within your Kubernetes cluster.
Not bad. No, that's not bad at all.
And then lastly, I'd like to add, if anybody is just getting started or getting their hands dirty, you're more than welcome to set up a free trial and you can launch all these clusters leveraging the Spot platform. So you can save those costs as you begin learning more about Kubernetes.
There's 2 questions on the chat.
Awesome.
Elvis says, who determines the amount of savings?
Yeah. So the savings is simply the aggregate of all the instances that are running today on Spot instances. We will track if they were to run as on-demand instances, what would they be at the MSRP price at the cloud? Then we track what is the actual cost that you actually paid. This is coming directly from your bill. So we're basically seeing what is the cost you paid compared to if you were to run the exact same infrastructure using the MSRP prices. And this will give you the total dollar save and then the percentage. So we're taking a percentage of that savings.
And there's another question. I'm not going to try to read the name, but the question is, saving related to what our current bill is if we are already using Spot reserve instances. We already use Spot and reserve, so that does not make any sense.
Yeah, I think I can address that. So pretty much the question here is because we're comparing to the MSRP price, this savings is skewed for that specific individual.
Reserve it because
exactly.
Okay.
They're already leveraging one of these pricing models. Therefore, the comparison should be really to what they currently pay today. So obviously, we're very flexible with how we do this. But again, you will see even with I've worked with many customers who today use RIs or spot instances today. We're actually able to gather additional savings because we're able to shrink the overall footprint of the cluster by up to 20% by maximizing those utilization of those nodes. But short answer is yes, we would make that more adjustable to meet your specific needs since you are already leveraging one of those other pricing models.
So that's something you do on the back end, or is that auto magic, or what do you?
Yeah, so again, the main takeaway here is we're providing the automation and the management of that infrastructure. So obviously the dashboard will say you saved X amount, but in reality, for someone who's already using reserved instances, this would be a much lower savings.
Yeah, gotcha. And then that'll be, you guys will calculate that out somehow.
Exactly. Yep, it'll just be a smaller percentage of the savings costs we would charge.
Gotcha. Do we have to tell you that we're using spot or RIs, or you already know?
Yeah, we'll be able to check. And one important element that I want to capitalize on is if you've already purchased reserved instances or you leverage on demand, which is the full MSRP price, we do not charge at all. And the reason why is because you've already paid for those reserved instances. We're not providing any benefit by leveraging them. We just want to make sure that we spin up your infrastructure and make sure that if there are any RIs, we use them so there's no waste. So for example, I have a couple on demand in here, and as well as you can see, I actually have some reserved instances that are being used because they were already purchased at a previous time before Spot came into the picture.
And you're calculating that, and then you're saying using those RIs is cheaper than doing something else.
Yeah, our method is you've already paid for it, why waste them? So we're going to make sure to spin up an on-demand so we can utilize that reserved interest purchase. And this does not go into the savings calculation. We did not generate any savings by leveraging on-demand or RIs.
That's neat. Cool.
Great
Any
question.
more questions out there? Cool. Thanks, Stephen.
No problem.
So, yeah, I didn't know that you guys only charged after the savings. That's interesting. Definitely gonna give this a try.